Assalamualaikum and hi. Hari ini kita akan bincangkan DAQ preparation for PSPM 2020-2021 SPO25. Kita akan bincangkan set A. We'll start with question number 1. Okay, this is question number 1. So let's read the question together. 2 point charges Q1 equals to positive 2 microcoulomb and Q2 equals to negative 3 microcoulomb are at position 0, negative 3 cm and 4, 0 cm respectively. The position of point P is 0, 3 cm. First, we have to calculate the magnitude and direction of the electric field at point P, and then we have to calculate the electric force experienced by a test charge Q equals to 4 microcoulomb, and the marks located here is 10 marks. Okay, we'll start with the first question. Okay, first we have to draw the diagram. So the diagram that we draw must base or refer to the question. Okay, so kita dah dapat diagram ini. Kita cuba lihat apa yang kita lukis dekat sini. So yang pertamanya charge Q1, okay, is at position 0 at x-axis and negative 3 at y-axis. Okay, and then we have Q2, negative charge, is located at 4 x-axis and 0 at y-axis. Okay, kita ada juga point P. Okay, so it is located at 0, 3 cm, 0 dekat x-axis dan 3 dekat y-axis. Okay, so kemudian kita kena juga lukiskan vektor I1 dan vektor I2. So vektor I1 dekat point P, kita tahu kita kena refer kepada charge positif dekat Q1. Charge positif ini kita tahu arah electric field dia adalah keluar daripada charge. Okay, so kita ambil titik P ni, tengok sambungan dia dengan charge Q1 ni. So kalau sini adalah arrow dia, so dekat point P ni arrow dia kena macam ni juga. Okay, kena follow the arrow dekat charge Q1 so that is the I1. Okay, lepas tu kita tengok pula vektor I2. So vektor I2 ini refer kepada charge Q2. So untuk charge Q2 kita ada charge negatif, so arah dia adalah masuk ke charge towards or into the charge here macam ni. So kita tengok laluan penghubung position P tadi ni, point P dengan charge Q2 tu. So tengok ini dapat apa. Okay, kita ikut lukis dekat sini. So we have vektor I1 dan arah vektor I2. Okay, next kita dah besarkan gambar rajah ni. Kita sudah ada I1, kita sudah ada I2. Apa kita nak buat? Kita kena cari dia punya theta. So kita ada theta kat sini. Okay, so di sini adalah 90 darjah. So kita boleh cari sin theta. Sin theta adalah opposite theta ni, opposite 4. Kita ada hypotenuse 5. So sin theta opposite over hypotenuse. For cos theta, adjacent bersebelahan bahagi hypotenuse. So 3 bahagi 5. Okay, next we have to resolve the vector I1 dan I2. So sebelum kita resolve kepada paksi X dan paksi Y, kita kira dia punya magnitude dia dulu. So magnitude I1, kita tengok rumus KQ1 over R1 square. So kita masukkan nilai. So Q1 charge positif, tak ada masalah. R dia mestilah jarak di antara P dengan charge Q1. So 3 tambah 3 dapat 6 cm. Make sure to convert into meter. Kuasa 2 kan. So ganti kena betul sebab dekat sini ada markah gantian sebanyak 1 markah. Kemudian kita kiralah pakai kalkulator untuk dapatkan magnitude I1. Next, kita cari magnitude E2. So, magnitude E2 pada charge Q2, Q2 ni charge negatif. Tapi jangan masukkan negatif sebab kita akan tengok direction itu kemudian. Gantian kena betul kerana kita dapat markah gantian dekat sini 1 markah. Dan the distance between point P to Q2 is 5. Point P sini, Q2 sini. So, jarak dia adalah 5 cm. Make sure to convert into meter dan squarekan. Dan by using the calculator, you get the magnitude for E2. Okay, next. Okay, sekarang kita kena resolve into X axis and Y axis. Okay, untuk resolve vektor ini, kita lihat dulu E1. So, untuk E1, vektor E1 sini, kita hanya ada paksi Y sahaja. So, paksi Y dia adalah 5 darab 10 kuasa 6, paksi X dia kosong. Untuk E2, kita tengok E2. So, dekat E2 ni, kita boleh resolve. Kita buat macam ni je. E2X, ini positif Ingat, ini adalah positif X, atas ni positif Y. Ni X sebelah sini negatif X, bawah sini negatif Y. So, ini bawah sini kita ikut arrow. Kita melindungi arrow ni Okay, so ini adalah E2Y. Ini arah negatif. So, dekat sini kita boleh letakkan negatif. So, E2 sin, sebab menjauhi ni sin. E2 paksi Y adalah mendekati ni, theta ni, so dia akan jadi cos. Okay, then we substitute the value. Ini value terkira tadi dekat previous slide. Kita ambilkan sin. Boleh cari theta, tapi later kita nak sinkan balik. So, why not kita ambil je terus 4/5. So, ini pun sama, kita ambil 3/5. Kita tambah dua-dua untuk vektor X. Kita dapat this one. Kita tambah dua-dua untuk vektor Y, kita dapat magnitude ini. Okey, dekat sini markah dia. Okey, kalau betul dua-dua ini, betul Betul, masuk kita dapat gantian 1 markah. Okey, lepas tu ini betul, masuk gantian. Sebelah kiri, paksi X, sebelah kanan, paksi Y. So, ini pun dapat gantian 1 markah. Okey, next step, the third step is we are going to calculate the magnitude. Sekarang kita akan lihat bagaimanakah cara untuk mengira magnitude. So, the third step is we are going to calculate the magnitude by using the theorem Pythagoras equation. Okay, so the total EP equals to this one. So, make sure substitute nombor kena betul. Kita ambil nombor yang ditulis sebelum ini nombor yang tulis ikut yang awak tulis tu So, ini dapat 1 markah. Okey, paksi X betul, paksi Y kena ada negatif, dapat 1 markah. So, jawapan akhir, pakai kalkulator, kita dapat jawapan akhir dan unit 1 markah. Okey, the fourth step is determine the direction. So, kita pakai equation tangent theta equals to summation EY over summation EX. Okay, substitute the value. So, make sure ada negatif kat sini. So, paksi X dan paksi Y betul. Dapat gantian 1 markah. Okay, so untuk jawapan akhir dan unit kena lukis. So, dekat sini negatif negatif Y. Ini adalah positif X. So, theta dekat celah sini. So, kita boleh dapat jawapan ni dengan lukisan, pastikan unit. Ada orang selalu lupa unit. Ni unit ni. Ni unit dia. Okey. So, jawapan akhir dan unit. So, dia kena tepat. Kalau tak nak lukis, kita tulis macam lah. Okey, in the fourth quadrant, at the fourth quadrant or below X axis. Okey, sekarang kita akan jawab soalan yang kedua. Calculate the electric force experienced by a test charge Q for microcoulomb. Okey, so kita gunakan equation yang biasa. Sorry, force, masukkan nilai. So, charge kita adalah charge positif. Okay, kita ada nilai E yang kita dah kira tadi. So, dua-dua ini kita akan dapat gantian satu markah. Kemudian kita kira by using the calculator, kita dapat nilai F. Okay, bersama dengan direction. Sebab dia charge positif, so dia akan dapat sama direction. Kalau dekat sini charge negatif, so direction dia akan jadi terbalik. So, ini akan dapat jawapan akhir dan unit. Dia sebut electric force. Electric force ini adalah vector quantity. So, when we are talking about the vector quantity, mesti ada magnitude and direction. Okay, So, kita dapat 2 markah kat sini. So, campur semua tadi 8 markah. Tambah dengan 2 markah, kita dapat. So, that's all guys. Thank you.
Okay, for question number 2 for set A, so given circuit of capacitor consists of 3 capacitor C23 in parallel and C123 dengan C12 dia series. So, kita settlekan. So, question dia nak determine the electrical energy stored in the capacitor. So, before we find the value of E, which is the energy kita, E equal to half CV square. Ini energy for the capacitor. So, C kita tak tahu. Given V dah ada, so kita kena find the C effective. So, kena settlekan sini dulu lah. So, C23 parallel. So, bila capacitor parallel capacitor, so C23 equal to C2 plus C3. So, our C2 is 2 micro. C3 is 3 micro. So, here we get 5 micro. So, C23 dah ada. Okay, tapi kita nak cari C123. So, here is C123. Bila kita simplify kan dia, circuit kita dapat macam ni. So, here is C1, here is C23. So, bawah ni kita ada power supply. So, here is C23. Kita just baru simplify kan circuit tu tadi. C23, here is C1. So, C1 dengan C23 is series. So, bila series, C123 equal to 1 over C1 plus 1 over C23. So, C1 kita, so 1 over 4 micro plus 1 over 5 micro, 1 over C123. So, jangan careless, kita nak C123. So, kena 1 over kan dia. So, sini kita dapat. So, C123 is 2.22 micro. Ni baru dapat C. So, dah dapat C tu, barulah kita boleh cari energi dia. So, E equal to 1 over 2 CV square 1 over 2. Dan kita timeskan dengan ini C kita 2.22 micro, the power of negative 6. Our V is 12 square. So, sini kita dapat 1.58 exponent negative 4 joule. So, jangan lupa unit dia. Okay, if you look at this question, markah dia provide is 3. So, macam mana nak dapat mark 3 tu? So, mark 3 tu, so dekat sini kita ada substitution G1. So, dekat sini lagi satu G1. And the last one is here. So, last mark GU1. Jangan lupa jawapan and unit. Okay.
A Figure 2 shows the arrangement of 4 resistors in a circuit. 1. Calculate the potential difference across R1. R1 equals to 5 ohm. So here we can use potential. So it means that V1 equals to V23. So V23 equals to I times R23. R23 here equals to 2 plus 1 because R2 and R3 are connected in series. So we substitute the value I equals to 4 ampere and R2 2 ohm, R3 1 ohm, so we can determine V1. So you get 12 volts. So the potential difference across R1 is equal to 12 volts. 3A2, determine the reading shown by the ammeter in the circuit. So you must determine I4 here. So before determine I4, so we must have I1, I cross R1. So we can use V1 equals to I1 R1. V1 equals to 12 volts and R1 equals to 5 ohm. So you can determine I1. So I1 equals to 2.4 ampere. So determine the reading of ammeter. So it means that I4. So I4 is equal to I plus I1. So we substitute the value. So we get I4 equals to 6.4 ampere. So the reading shows by the ammeter in the circuit is 6.4 ampere. B. The internal resistance of all the batteries in figure 3 are negligible. Calculate the current I1, I2 and I3 when switch S is closed. So here we have 3 EMF. We have 3 EMF here. So now we have 2 junction and we have 1 loop, 2 loop. So we can apply Kirchhoff law. First, we can apply first law at any junction. I summation IE must equal to I out. So junction here we can use junction Y. So I in here is I1 and I out here is I2 and I3. So you can determine equation for first law. I1 equals to I2 plus I3. So we rearrange this equation. So you get I1 minus I2 minus I3 equals to 0. So this one is equation 1. For equation 2, we apply second law. Summation EMF equals to summation I times R. So we can choose loop. So let's say this one is loop 1. Okay. Rotate anti-clockwise. So total EMF here, we have 2 EMF, we have 7 and 6 EMF. So total EMF here equals to 7 plus 6 volt. Equals to IR. Okay, we have 3 ohm and I here is I1 positive. And here we have 4 ohm and I cross 4 ohm here is I3. Also positive. So substitute the value. So you get 7 plus 6 equals to 3i plus 4i3. So we rearrange this equation. So this one is equation 2. Then for equation 3, so we apply loop 2. Here is loop 2. So equation for loop 2. So you get 6 plus 5 equals to 3I1 plus 2I2 plus 1I2. So we rearrange this equation so you can determine equation 3 here. So you get equation 3, 3I1 plus 3I2 equals to 11. So we have 3 equations. So we use calculator to determine I1, I2 and I3. So you get I1 equals to 2.52 ampere, I2 equals to 1.15 ampere and I3 equals to 1.36 ampere.
Okay, Assalamualaikum warahmatullahi wabarakatuh, and hi to all of you. So now we will discuss question number 4, which is chapter 5, Electromagnetic Induction, and the contribution marks for this question is 10 marks. Okay, and we have two questions, 4A and 4B. Look at to the first question, 4A. A solenoid has self-inductance 4.5 microhenry. If the current in the solenoid decreases uniformly from 5.5 ampere to 0 ampere in 2.5 microsecond, determine the magnitude of self-induced EMF through the solenoid. So as usual, list out all the information given from the equation before you proceed with the calculation. Okay, so L is 45 micro, which is 10 to the power of negative 6 Henry. And the current, it was stated as decreases. Okay, the current decreases from 5.5 to 0. So it means your DI is negative 5.5 ampere. Why negative? Okay, because of the changes current, it should be final value minus with the initial value, and the final value is 0 while the initial value is 5.5. That's why we get the change of current is negative 5.5 ampere. Okay, next we have the time interval. Your dt is 2.5 exponent negative 6 second, because micro, right? So micro is 10 to the power of negative 6. And you need to determine the magnitude of self-induced EMF, and the symbol is like this. Okay, pump, question mark. Okay, now check the information. You have L, you have the DI, you have the DT. Automatically, the equation is induced EMF equals negative L DI over DT. Okay, simple. And don't forget, this negative is compulsory. Okay, compulsory in our equation. So now, negative, your L is 45 times 10 to the power of negative 6. And the DI is negative 5.5. And the DT is 2.5 times 10 to the power of negative 6. Okay, now you can use your scientific calculator, whereas this one can be cancelled out. So, negative become as a positive. So, 45 times with 5.5 over 2.5, we get 99 volt. Okay, and we want to determine magnitude. Okay, just the value. Therefore, you can make a conclusion. The magnitude of induced EMF is 99 volt. Okay, settle for the first question. Now second question for B. Okay, for B. You have a diagram, figure 4. So this one is figure 4, okay? Okay, figure 4. Okay, so let's read the question. A long solenoid and wire loop are placed as shown in figure 4. The solenoid has 600 turns with the length of 1.50 meter and the cross-sectional area is 4.2 centimeter square. The current that flows in the solenoid is increasing at a rate of 120 ampere per second. So for number 4B, the current, it was increasing. While for B just now, for the 4A, it was decreasing. Decreasing means negative. Okay, increasing, positive value. Okay, so as usual, list out the information. Okay, for the solenoid, we have the number of turns. So I make it SN1, 600 turns. And you have the length, 1.50 meter. And the cross-sectional area is 4.20 centimeter square. So this centimeter square, you need to change to the meter square because your L is in meter. So you need to make sure it's in the same unit. Okay, so just change it, 4.20 centi square. So centi is 10 to the power of negative 2 and then square it, you will get 10 to the power of negative 4 meter square. Okay, it is like this lah. Okay, centimeter square. Okay, so and the centi is 10 to the power of negative 2 meter, square it, so become as negative 4. Be careful with your unit conversion, okay? Alright, and the last information you have is the rate of change of current, di over dt, 120 ampere per second. Okay, then look at to the coil. Okay, coil actually, if you refer to this diagram, you just have one turn. So that's the information that you have for the coil, which is you have the N2 is one turn. Okay, the first Roman, you need to calculate the magnitude, magnitude of induced EMF in the wire loop outside the solenoid. Okay, outside the solenoid. So the first Roman, we want to determine the induced EMF. Okay, in the wire loop, not the solenoid. Okay, in the wire loop. Alright, look at to the diagram given. Okay, you have the change of current in the solenoid. Okay, so when the current was changing in the solenoid, it will be influenced the magnetic field occur in the wire loop. So wire loop, wire loop occur the mutual induction due to solenoid. Okay, so this is the mutual induction process. Okay, that's why to calculate the induced EMF, okay, the equation that you need to use is induced EMF equals to negative M. Okay, negative M di over dt. Okay, why we use the mutual? Because loop depends on the solenoid. Okay, so this is the mutual. Okay, mutual process. Okay, so just substitute into equation. Oh, sorry. Okay, look at to the information. You have the DIDT, but you don't have the M. Okay, so you need to find out the M first. Okay, so the equation for the mutual inductance is mu naught N1 N2 A over L. Okay, so just substitute into the equation. Mu naught is 4 pi exponent -7, and N1 stand for the solenoid. You have the 600 turns, and the N2 stand for the coil, okay, the loop, 1 turn, and the area of the solenoid is 4.20 exponent -4. And the last one, you have the length. The length, I forgot the value, 1.5. Okay, 1.50. Okay, so determine the mutual inductance. And we get 2.11 times 10 to the power of -7 Henry. Okay, after that, substitute in your basic equation or your first equation. So induced EMF equals to negative, and the mutual is 2.11 times 10 to the power of -7, and the rate of change of current given is positive 120. Therefore, the value of induced EMF is negative 2.53 times 10 to the power of -5 volt. Okay, we get the negative sign of induced EMF because of the rate of change of current is increasing, positive. Okay, and we want to determine the magnitude. Okay, just magnitude. Magnitude is the value. Value is nilai. Okay, so we make a conclusion. Therefore, the magnitude of induced EMF is, we take it the positive sign, positive 2.53 times 10 to the power of -5 volt. Okay, settle for the first Roman. Now look at to the second Roman. Okay, second Roman, we want to determine magnitude and direction of induced current within the wire loop if its resistance is 2.5 ohm. So now you have the value of resistance of the loop is 2.5 ohms. Okay. And you also have the induced EMF for the coil 2.53, which you had calculated just now. Okay, times 10 to the power of -5 volt. Okay, and how you want to determine the induced current? Okay, you have the induced EMF, you have the resistance. So just use induced EMF equals to induced current times with the resistance. Then just substitute the values because it is the magnitude. Magnitude, choose the positive value. Induced current and the resistance is 2.5 ohm. Therefore, induced current is 1.01 times 10 to the power of -5 ampere. Okay, settle for the magnitude. But then, what happened to the direction? Okay, direction of induced current. So the direction of induced current, you need to refer to the diagram. Okay, to the diagram, which is when we increase, the current, means the magnitude of magnetic field, the magnetic field line will be increasing. Okay, your B increasing. But then for T, the Lenz's law, stated as it will be oppose any changes. Okay, any changes. So we will have the direction of induced magnetic field in opposite direction. Okay, after that, you just use your right hand grip rule, okay, to determine the direction of induced current occur in wire loop. So just grab it, so you will get in this direction. So this is the induced current. Okay, so we can see that the direction is in anti-clockwise. Simple. Okay, so this is anti-clockwise. Okay, that's it for question number 4. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And hi everyone. So now we will look at topic 6, alternating current, which contribute 10 marks. So question A, a voltage V equals to 20 sin 100 T is applied across a 10 ohm resistor where V in volt and T in seconds. Determine the current when T equals to 10 seconds and the amount of heat produced by the resistor in 3 minutes. So when we have question T equals to 10 seconds, we need to use equation I equals to I naught sine omega T. So we need to find I at T equals to 10 seconds. So we are going to apply this equation I equals to I naught sine omega T. So we need to find I naught first. From the Ohm's law, I naught is equals to V naught over R. And our V naught here is equals to 20. And R equals to 10 ohm. So we get our I naught equals to 2 ampere. So substitute all the values of I naught, omega and also T. We get I equals to 1.66 ampere. So 1 mark will be give to I naught and another one is for the I equals to 1.66 ampere for JU1. And for question number 2, we need to find E at T equals to 3 minutes. So we know that E is equals to PT, where P is equals to I square R. And this I is referring to IRMS. So find the IRMS first, where IRMS is equals to I naught over Z2 and our I naught just now is equals to 2 ampere. So this will be the answer for IRMS. So substitute I RMS, R 10, and T is 3 minutes change to SI unit, which is second. So we get our E equals to 3600 joule. So this will be J1, G1, and final answer is JU1. Question B. A 3200 picofarad capacitor is connected in series to 30 microhenry coil and 5 ohm resistor across a source of alternating potential difference of 50 volt. So we have C, L, R, and VRMS. Calculate the impedance at frequency 50 kHz and the power factor of the circuit. So omega is equals to 2 pi f. Okay, substitute the value of f equals to 50 kilo, and we get omega equals to 100 pi times 10 power of 3 radian per second. So we have R, C, and L. Okay, we know that L is upwards, C is downwards. So XC equals to 1 over omega C, omega, and our C is 3200 pico. Pico is power of negative 12. So we get XC equals to 994.72 ohm. For the XL, omega L, substitute the values of omega and L, we get XL equals to 9.42 ohm. So here will be the marks for J1, J1. Okay, so from the phasor diagram of impedance, XL 9.42, R 5 ohm, and XC 994.72. And our impedance formula for RCL circuit, it is R square plus XC minus XL square. This is from the theorem Pythagoras. We can find the vector Z from equation vector of X and Y. So our x-axis here is R plus 2, y-axis is XC minus XL because XC is greater than XL. So substitute all the values, we get impedance equals to 985.31 ohm. So we get 1 marks for the gantian and JU1 for the jawapan and unit. Continue to question number 2. We need to find the power factor. We call it as cos phi. So the formula for cos phi is equals to R over Z. So substitute the value of R and the value of Z. We get cos phi equals to 5.07 times 10 power of negative 3. For this question, we get GJ1.
Assalamualaikum warahmatullahi wabarakatuh, and hi. We're going to discuss the solutions to question 6, which is on Geometrical Optics from DAQ Set A. So let's look at the question right away. This is 6 part A. A makeup mirror has a focal length of f if the mirror produces a magnification of 1.5. When a person's face is 12 centimeters away, calculate f. Okay, since this is a mirror, and the person's face is 12 centimeters away, so it means that this is the object. So u has to be equal to 12 cm. Okay, let's calculate f. Okay, what's the focal length of the mirror? After listing down the information, we now have the value of m equals 1.5. So if you want to use the mirror equation, 1 over f equals 1 over u plus 1 over v. We know the value of u, but how about v? Okay, to find v, let's use m equals negative v over u. And m is 1.5, negative v, u is 12. Therefore, v is equal to negative 1.5 times 12. Okay, let's calculate these numbers. You'll get negative 18 cm. Okay, knowing the value of v, we can now calculate focal length using the mirror equation that we wrote at the beginning of the solutions. So 1 over f equals 1 over 12 plus 1 over negative 18. Okay, don't forget the negative sign, that's very important. Carry out the operation, and that should give you the answer where focal length is equal to positive 30 cm. Okay, this positive sign may look redundant, but it's very crucial in determining the type of mirror, which is our next question. Okay, so your next question is stating the type of mirror used to produce this amount of magnification. So as I said just now, because f is a positive value, it means that my mirror is a concave mirror. Okay, how do I know that? It's because using the sign conventions that we learned in this chapter, concave mirror focal length has to be positive. Okay, so that's how we solved question 6 part E. Let's now continue to part B. An object is placed in front of a concave mirror for which f is equal to 30 cm. So concave mirror, f equals 30 cm, where must the object be placed? So objects, so that the image is 4 times larger. These are all the information given in the question. So let's decide how we're going to solve for number 1 and number 2. So we know that f is equal to positive 30 cm because the type of mirror is concave. Where must the object be placed? So in essence, we are calculating the value of u. Okay, because where must the object be placed? Position of the object or distance of the object from the mirror. So what's the value of u? That's what we're trying to determine when the image is 4 times larger. So anything about the size of an image, it must be referring to the value of m. It's just that for the first part of the question, m is equal to negative 4, because negative 4 meaning this negative sign signifies that the image produced is a real image. We know from the acronym that we learned in this chapter, RIVU, real image must be inverted. Okay, real image must be inverted, and this negative sign means that your image is inverted. Therefore, your image has to be real. So when m equals -4, how do we find out the value of u? Okay, let's use m again. M is equal to -v over u. Because m is -4, it's -v over u. So I'll get -4u equals -v. Get rid of these negative signs. V is equal to 4u. So now we're stuck because we have two unknowns. So whenever you see two unknowns in a problem, we need two equations to solve it. So V and U. So what's the other equation that we need to write down? We know about the mirror equation. We're very familiar with this equation. So we want to find U. Let's remind ourselves that we want to find U. So let's substitute 1 over 30 equals 1 over U plus 1 over 4u. Okay, so times 4 times 4. Let's make the denominator the same number. So I'll get 4 plus 1 over 4u equals 1 over 30. And 5 over 4u, 1 over 30. Okay, so 1 over 30 is equal to 5 over 4u. Let's do some cross multiplication. And in the end, the answer that you'll get, I hope it is the same as mine, is positive 37.5 cm. Okay, but we didn't exactly answer the question because it says where must the object be placed. Now we know that u is 37.5. We should put the object 37.5 cm. This is a positive sign, so it must be in front of the concave mirror. Concave mirror. Okay, next we're going to try doing the same thing to equation B2. The actual difference is now image is also 4 times larger, but the image is virtual. So what do we know about a virtual image? It is upright. So upright. When the image is upright, the sign convention that you should use is positive. Okay, so positive 4. When m equals positive 4 and f equals 30 cm, what's the value of u? So we are basically repeating the same thing that we did for equation number 1. So m is equal to 4, and m is also equal to negative v over u. So f 4u is equal to negative v. I'm gonna try and make v positive. So that's equal to negative 4u. Mirror equation, let's write it down again. 1 over u plus 1 over v, 1 over f, 30, 1 over u plus 1 over negative 4u. Okay, now choosing the same denominator, 4 and 4, so 4 minus 1 over 4u, 1 over 30, 3 over 4u, 1 over 30. And in the end, u is equal to positive 22.5 cm. Okay, the answer is also positive. Hence, the object must be also placed 22.5 cm in front of the mirror. Okay, so in front of the mirror. So I hope you understood the way we solve this question. Please pay attention to the sign convention for M magnification. Okay, let's proceed with the last part of the question. C, focal length of a converging biconvex glass lens with refractive index n equals 1.5 in air is 20 cm. Calculate the radius of curvature of the lens. So now we're talking about a biconvex glass lens. So this is how it looks like. Okay, how do we determine the radius of this lens? Okay, let's use lens maker's equation. The equation is 1 over f equals, this is in air, so n minus 1 divided by 1, because n equals 1 for air, 1 over r1 minus 1 over r2. Okay, to get this question, to get the answer correctly, you need to determine the sign conventions for R1 and R2. So R1, we start from the left. This is R2. R1 is positive. R2 is negative. Okay, it's because of the curve. Okay, this is convex. So R1 is positive, R2 is negative. Let's substitute those values into a formula. 1.5 is the refractive index, 1.5 minus 1. For this type of biconvex glass lens, R1 is equal to R2. I'm going to assume these values as R. Okay, so 1 over R minus 1 over R. Okay, because the values, they have to be equal. Focal length is 20. So solving that will give you 1 over 20, 1.5 minus 1, 0.5. Then 1 over, I'm missing the negative sign. This should be negative, yeah? Negative, negative, positive. So 1 over R plus 1 over R is 2 over R. Okay. And using your mathematical expertise, you're going to find out that R will eventually be 20 cm. Okay, so that's the value of radius of curvature of the lens. Okay, let's finish this up with question number 2. If the lens is placed in a liquid of refractive index n equals 1.63. So we are putting this lens, immersing this lens in a liquid with this value of refractive index. So remember your lens maker's equation again. Is n material over n medium minus 1 over R1 minus 1 over R2. Okay, what is n material? It's the material that the lens is made of. So it's obviously stated in the equation that the lens is made of glass. So n material is n glass 1.5. We are immersing the lens in a liquid of refractive index 1.63. So medium is where you immerse the lens in, and minus 1. And what was the value that we got from equation number 1? It's 20 cm. So 1 over 20 minus 1 over negative 20. Because R2 is negative. Remember that convex lens? R1, R2. Positive, negative. Okay, calculate. Just plug in all the numbers into your calculator. And finally, the answer is negative 125 cm. Okay, this is our new focal length. And what type of lens this becomes? It becomes a diverging lens. Because now f, the value has shifted to a negative value, so it becomes a diverging lens. Okay, so that's all for question 6 set E. Thank you.
Question number 7. Physical optics contributes to 10 marks. 7A1, light from a helium neon laser lambda equals to 630 nm is used to illuminate a double slit. The interference pattern is observed on the screen 1.8 meter behind the slits. 9 bright fringes are seen, spanning a distance of 48 millimeters. Determine the spacing between the slits. Okay, from this question that you are given 1.8 meters, meaning that this is T. 9 bright fringes are seen, spanning a distance of 48 mm. What is T's value? Later we'll discuss. Determine the spacing between the slits means we want to find out T. Okay, so I suggest to you to sketch the interference pattern. And given here, there are 9 bright fringes are seen. Alright, so I will start with at the center. At the center is central bright fringe. So I label the order number. The order number that I label are referred to the bright fringe. Start with M equals to 0. And then dark and bright. So I have to label or draw the bright fringes for both sides. M equals to 1. Okay, upper part dark and bright. M equals to 2. Lower part dark, bright. M equals to 2. Okay, next M equals to 3. Over here also M equals to 3. Okay, next dark and bright. M equals to 4. And then bright, M equals to 4. Let us count how many bright fringes can be seen here. Start from center. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 bright fringes. Okay, and the distance is 48 millimeters. But actually when we want to measure the distance, we start from the center and we label here as YM. Okay, M here you have to take as Y4. So meaning that there are 2 Y4 here. Y4. Okay, so in this case, 2Y4 equals to 48 millimeters. So what is Y4? Y4 equals to 48 divided by 2. So you get 24 millimeters. Alright, what is the formula for Y4? Y4 or Ym equals to M lambda D over D. Okay, so in this case, M equals to 4. So Ym or Y4 equals to 24 times 10 to the power of negative 3 equals to 4. Lambda is 630 times 10 to the power of negative 9. D is 1.8 and over D. So we calculate, you get D equals to 1.89 times 10 to the power of negative 4 meters. Okay, how about this, the mark? Okay, the mark here, there are 3. Number 1, how you get the value for y4? 48 divided by 2, that is for k1. Okay, next, you substitute all the values, you get j1. And then final answer here, you get ju1. 7.2, a film with n 1.60 is deposited on glass n equals to 1.50. What is the thinnest film that will produce destructive interference in the reflection of light with a wavelength of 590 nm? Okay, so let us sketch diagram. Here is the thin film, n equals to 1.60 with thickness T. Okay, and then on top of it is air, and 1 equals to 1. And here is the glass, and 2 equals to 1.50. Firstly, we draw the incident light. This is the shape of the wave of incident light. After that, it will reflect. So this is the first reflected light. Okay, to know whether this light experience phase change or not, let us compare n between n film and n for air. It is found that n for film is greater than n for air. So there is phase change. Alright, so what is the shape of the light? So this is the shape of the reflected light. Okay, next, this light pass through this film and again reflect. So this one is the second reflected light. So is there any phase change for this light? Okay, let us compare the n for glass and n for film. So it is found n for glass is less than n for air. So means no phase change. So the shape of the wave for this one same as for incident light. So now after that we compare these two reflected light. It is found that they are in anti-phase. So the technique used to know the formula that we are going to use is IC Madam. So over here, this is anti-phase. So for anti-phase, for destructive, we use m lambda. So the formula is 2nt equals to m lambda. Next, substitute all the values. 2, n is for film 1.60, t, m. What is the value of m? Since this is the thinnest film, so m should be equals to 1. Lambda 590 times 10 to the power of negative 9. And calculate t, you get 1.84 times 10 to the power of negative 7 meters. How about the mark? There are 3 marks for this question. Number 1, mark for m that you substitute is 1. That is for K1. Next, you substitute as G1. And final answer with correct unit as JU1. For 7b, a 1.2 cm wide diffraction grating has 1,500 slits. Is illuminated by lights of wavelength 670 nm. How many diffraction orders are seen on the screen? In this question, we want to find out m. Okay, and then over here you are given n equals to 1,500 per 1.2 centimeter. Okay, so what should we do? Okay, so we have the formula d sine theta equals to m lambda, and d equals to 1 over n. So in this case, substitute 1 over n given as 1,000, n equals to 1,500 per 1.2 cm means 1.2 times 10 to the power of negative 2. So you calculate, you get 8 times 10 to the power of negative 6 meter. Okay, after that, substitute into this formula. In this case, the value of theta you have to take as 90 degrees. So substitute all the values. D sine theta equals to m lambda. So D is 8 times 10 to the power of -6 sine 90 degree equals to m, and lambda is 670 times 10 to the power of -9. So you calculate, you get m equals to 11.94. So here we have to take m equals to 11. So the mark here is 4. How to get 4? Firstly, you calculate the value of D. You get G1. Okay, next, for concept, you choose theta equals to 90 degree and you substitute the values here as G1 and finally the answer.
Hello, Assalamualaikum warahmatullahi. Now look at question number 8. So question number 8 ni actually question from chapter Quantization of Light. So given is the work function. So what is work function? So remember work function is W naught. W naught equal to HF naught. Next, the first question asks to calculate the lowest frequency of the light. So lowest frequency here refer to the F naught. So for question A, we are going to find F naught. So by using W naught equal to HF naught, F naught equal to W naught over H. So W naught already given, which is 4.6 exponent -19 over H. H is 6.63 exponent -34. Then we get the lowest frequency or threshold frequency is 6.94 exponent 14, and don't forget to write the unit is hertz. Okay, settle for A. Then we go to question B. Question B, what is the maximum speed? Maximum speed meaning we are refer to V of the electron emitted when light of 7.3 exponent 14 Hz is used. So ini soalan photoelectric effect, and the equation for the photoelectric effect is E equal to W naught plus K max. So W naught kita dah ada. Now kita nak cari maximum speed. So the maximum speed is V. And so from this equation, so actually K max tu sebenarnya, so K max equal to half mv square. So kita boleh dapat V kita from equation of K max. But before that, we have to find the value of K max, which is K max kita equal to E minus W naught. E equal to HF. So E kita dah ada, E is HF. So kena calculate dulu lah, minus dengan W naught. So HF kita 6.63 exponent -34 time with time with F. F is 7.3 exponent 14 and minus dengan W naught 4.6 exponent -19. So kita dapat K dia 0.24 exponent -19 joule. But question bukan nak K, tapi kita nak cari V. So dari sini, so kita dapatlah V dia. So we just substitute the value of K max. So K max ni half mv square equal to 0.24 exponent negative 19. So V equal to, so we substitute, M is mass of electron. So sini kita dapat 2.3 exponent 5 and the unit is ms negative 1. Okay. Okay, kalau kita tengok marking marks dia dekat mana. So first kita ada mark dekat sini. So here kita ada mark for concept K1. Lepas tu kita ada G, JU1, G gantian yang ni. Lepas tu ada jawapan with unit, mark. Lepas tu kita ada konsep dekat sini. So K1, here kita ada G1. So last kali JU1. So total kita ada 1, 2, 3, 4, 5 marks. Okay.
Okay guys, so let's continue by question number 9. So what is the question? An electron moves with a speed of 5.4 exponent 6 meter per second. Calculate the de Broglie wavelength of the electron. Okay, so based on this question, by giving you the speed, they ask you to calculate the wavelength of de Broglie. Okay, how is it? Okay, first, by using the equation of P equals to mv, so P is momentum equals to mass multiplied by the speed, which is given here. We just substitute into the equation where the mass now is a constant, which is mass of electron equals to 9.11 exponent negative 31, and the speed given already here, so that you will get the momentum. So by getting the momentum, then by using the de Broglie relationship, which is lambda equals to h over p, we just substitute the value of p calculated just now, where h just a constant, so that you will get the value of wavelength. Remember, h is the Planck constant, which is 6.63 exponent negative 34. So by using our calculator, and then you will get the answer, which is equals to 1.35 exponent negative 10. Okay, next for question number 10, which is under nuclear. Okay, what do we have? Alright, so there are two questions, which is 10A and 10B. So we just discuss it one by one. Okay, starting by the first one, which before that, okay, according to this question, seems like 10A2, this is out of syllabus. Okay, because we are discussing about induced reaction, where we need to bombard the nuclei using other particles, then giving you two different nuclei. That one is under fission process. Fission is under induced process. It's not instantaneous process or spontaneous process. Sorry, it's not spontaneous process. So that this is out of syllabus. So by having something like this, remember in exam, don't leave it empty. You need to write something. For example, just write down all the questions relate to the chapter. And then by getting something wrong with the question, you will get some bonus mark lah. Don't leave it empty. Okay, so write down the question. So for this question, we are going to discuss question number 10A1, also 10B only. Okay, alright, so 10A1, the question is, okay, sketch a graph of binding energy per nucleon against nucleon number. Okay, so I think it's quite simple. Okay, we just take out the axis, which is binding energy per nucleon again nucleon numbers, and then we just take out the curve here. All right, something is wrong here. Don't forget that. Okay, we need to complete the axis with the arrow. Okay, to be like this. Make it complete, yeah. Okay. All right, next, number 10B. The half-life of radioactive source is 435 years. How long it will take for its activity to reduce from 4.2 Curie to 0.16 Curie. Okay, what do we have now? First, they just give you the value of T half. This is T half. Okay, and then what do we have? The initial activity, which is A naught, and the final activity, which is A. Okay, but remember the unit just in Curie, so this is not our SI unit, isn't it? So we need to convert it to be in SI unit. But okay, it depends on the situation. For any ratio method, it's okay using Curie because they will cancelling each other. Okay, we just check it first. Okay, so now by giving you the half-life, also the initial and final activity, they ask you to find, okay, how long it will take. Okay, so this is the time needed, isn't it? Okay, so they ask you to find the time lah. So by knowing activity, initial activity, final activity, and half-life of the radioactive source, okay, how do we calculate the time? Okay, so by using the equation of activity directly, activity equals to initial activity exponent negative lambda t. So lambda is the decay constant and t is the time needed here lah. Alright, so A not given already, also A, but lambda is not given, isn't it? So that we need to calculate lambda using T half. Okay. Alright, so by arrange the equation, you will get like something like this, where exponent lambda t equals to A naught over A, and then by having ln for both sides, you will get this. And remember, lambda is ln 2 over T half. Lambda is ln 2 over T half. Alright. Okay, something is missing here. Sorry again. So we got T here. This is T. Okay. So lambda equals to ln 2 over T half. T half given already. So this is T, the time needed. Okay. A not also given. And A given to, as I told you before, we are talking about a ratios in it. So for this, you don't have to convert the unit because Curie and Curie, they are cancelling each other. Okay. So mathematically, you may calculate the time needed here, which is equals to 2050 years. All right. So this is the way how do you answer the question.